Thank you. Okay. I think you guys should already be able to see my screen. Now let me go ahead and launch in. So what I'm going to talk to you about is basically a different way to use your Python in order to get into production faster. It's like everybody knows that they work really hard on data science, on machine learning, and then a lot of times it just never makes it into production. There's an estimate, depending on which survey you look at, between 60 and 90% of projects never make it into production where they're actually benefiting their company. And you don't want to be seen as a cost center, you want to be seen as a benefit to your company. So how do you get your Python projects into production faster? My theory is that if you use an MPP database, and since I work for Vertica, I obviously think you should use Vertica, but there are other MPP databases out there that you can do machine learning in. So this does not just apply to my product, but certainly go visit the Vertica booth if you want to learn more. So also my presentation has nothing to do with space, but I'm a space geek, so I'll figure out a way to make that work. Okay. So first off, this is a slide I stole, with permission, of course, from the senior data scientist at Philips. And the reason is he did a presentation on how his company does machine learning, how they get it into production. And I realized looking at that slide that it was a very succinct way of explaining how everybody does machine learning in production. So this is the general idea. It's like, so you have a live stream coming from somewhere. In this case, it's from all the components of the Philips MRI machines and CAT scanners and all of the things they make. Every component sends a live stream of information. Now they accumulate that information in a sort of a historical repository of some sorts. They put it all together in one big place over time. So the last, 5, 6, 7, in their case, like 10, 20 years worth of data is all stored in one place. And then they combine that with a lot of relational data. So you get data about maintenance calls, you get data about how long has this company owned this product, you get data about how old is the product. You get all this information about that's in these relational databases, and you combine that with that historical device data, and then you do some machine learning on it. You integrate that together, and you try and find the patterns. And in this case, their use case is predictive maintenance. So they're trying to find the patterns that indicate a component is about to break. Now, the goal, of course, is so that that MRI machine or CAT scanner or whatever that somebody really needs in order to, save their lives, doesn't it doesn't fail and have downtime, which might cost lives. So that's a big thing. So they want to be able to tell when it's about to break and go in and fix that component at that particular location, sometime when the machine isn't being used, say at 3 a.m. or whatever, and they fix it, and then it goes on and it never has any downtime. So that is their goal. That is going to be the value that they bring to their company if they can accomplish that. And this is very similar to how almost every machine learning project works in production. Now, the essence of this is they have petabytes of data to go through because those devices have been sending every single component in every single device has been setting information for years. And so when they monitor that, it's like they've got to be able to have the pipelines function at high scale and be able to accomplish this, even though most of their data scientists work in R or Python. So they like to work in Python. This is kind of what that Philips looks like from the architecture standpoint. So you have that low latency data, and they actually started this way before Kafka and Kinesis and a lot of those other things. So they did their own pub/sub network, and they do some stream processing, and they put that data for the fast response right into their MPP data warehouse, which is Vertica in this case. And they take their batch data, all their their repair shop data, their factory data, their customer data, their maintenance logs. All that information goes into a big data lake, and that is also where all of their historical device data goes. And that's where that's combined. And instead of trying to do their data science there, they actually go ahead and put all of it into that MPP data warehouse. Why? Well, because now they can take their Python and their R, and even in some cases they can do data science with SQL, and they do it in the database. They do a lot of data preparation. They train their models, they manage their models, and the nice thing about the MPP data warehouse is it distributes those models across as many nodes as needed, because that data warehouse is MPP. It's distributed, it grows as your data grows. And that also, because it is very happy with R and with Python, it will distribute that work as well. So even though R and Python aren't themselves designed to work at that scale, the MPP database gives them that capability. So why? Why is this awesome? Why does Philips do it this way? Philips and a lot of other folks at this point are doing it. Well, what does machine learning at scale need? Well, it needs speed, because you have a high amount of data. You have to process it very quickly. In some cases, the Philips SLA is not that fast, as long as they catch a component before it breaks and in time to schedule a maintenance, they're okay. But some things like ad targeting need, 200 millisecond SLA. Like if you have 15 petabytes of data and you have a 200 millisecond SLA, you better have some fast data processing. So you need that. It needs to be fairly easy to use, because if you want this to be more broadly used, it needs to not be that hard. It needs to be something that you can develop quickly. And that's really what ease of use means, is you get a faster time to production. You got to have a wide variety of features. It has to be able to do a lot of things. And it has to be flexible. It has to be able to change the way it needs to do things. It needs to be able to handle different data sources, different algorithms, different modes of deployment. Do I want it on the cloud? Do I want it on-prem? Do I want it on Amazon? Do I want it on Google? It's like, do I want it hybrid? Do I want it multi-cloud? It should work no matter what. So that shouldn't have a bearing on whether or not this can be accomplished, and you need to be able to integrate with all the other things. Philips built their own pub subsystem, but most people want to use Kafka, most people want to use Kinesis, they want to use Pulsar. You got to be able to integrate that. You got to be able to work with Tableau and Looker and Power BI and all of those other display capabilities. So that kind of gives you an idea. So like, what does machine learning need? Well, what does Python bring to the table? Anyone who uses Python knows it is one of the most broadly useful programming languages, especially for data science. If this is what you're trying to do, Python is the way to do it. It just has a lot of capabilities in this area. It's incredibly flexible. It will work anywhere. It will work on my phone, it will work on a laptop, and it will work on a distributed system, although it doesn't have that parallelism built in necessarily. It's not necessarily that great at scaling up, but it has the ability to work wherever you need it to work. And it's very easy to use. As programming languages go, I have to say Python is one of the easier ones, although I think that indenting thing is bananas. Every other programming language I ever had to learn had indenting as a best practice, but this one actually gives you a syntax error if you're off by a space. But aside from that, Python is awesome, and it will do a lot of things very quickly. You can use a few lines of code to do a tremendous things that would take far more effort in other languages. It has a really strong community. That's a big one too, because new libraries are being developed all the time. You have pandas, you have scikit, you have matplotlib, you have numpy, you have all of these things that are really useful to get your job done, and they're growing all the time. We have a huge community that's adding to it at all times, and that's pretty awesome too. So Python is really great. What else is it really great for? Well, it's really great for all of the use cases that you kind of need. So you want to do predictive maintenance? Python is the way to go. You want to do A/B testing, you want to do clustering for targeted marketing, you want to do ad targeting, you want to do smart agriculture, smart buildings. It's like all of the things that cybersecurity, all the things that you need to do right now with machine learning, Python is an excellent choice for. Well, why doesn't everybody use Python? And the answer is that Python isn't great with scale. When you have also concurrency. So if I have 5 users and they want to use Python all at once, that's not too much of a problem. If I have 100 users and they want to do the same thing, now we have a problem. If I have 1,000, forget it. It's just not going to work. Python is just not designed for that level of concurrency. And it's also not designed to work across a cluster and split your job up and run in parallel. You have interpreter lock issues and CPU thread management issues, and all this problems that you have are really about getting Python to work at scale for an enterprise. So for a larger company or a company that has a whole lot of data, not necessarily a big one. So let me think about it's like, okay, so everybody knows when I do data science, I don't do data science and boom, I'm done. Yay, I did data science today. That's just not the way it works. First, you gotta kind of understand, okay, here's a problem that I might be able to tackle, and then you explore your data and you're like, yeah, I think the data that I need to answer this question is in here. And then you prepare the data like crazy. There's all these different steps to get the data clean and together, and then you train a model and you evaluate the model, and that model sucks, and you start over again and you go all through the whole process again, and eventually you model something, you evaluate, and you're like, this is it. This is the model that's going to save my company a whole bunch of money, or it's going to I keep this MRI machine from breaking that somebody needs to stay alive, or it's going to save a bunch of IT costs or whatever. This is a great model. And you're like, hey, this is great. Bam, I hit a wall. Why? Well, getting that model into deployment for production is the hard part. A lot of times you have to hand it off to some data engineer who then has to rebuild everything you did. It's like, oh, you did 25 steps in your data preparation. Well, I have to build a scaled pipeline for all of the data that does every one of those 25 steps before you can then put your model to work and have it predict out on that data. It's like that's a big job, and it's like, oh, well, that's going to take me 6 months. It's like, well, the model is great now. In 6 months the data is going to drift. How accurate is that going to be? Yeah, so you can see the problem of trying to get this into production. So what do? How do we fix this? Well, subsampling is a problem, obviously, that can compromise your accuracy. Everybody knows that more data even beats a better algorithm in machine learning. So the more data you have, the better. Well, why don't we work with all of your data? Well, that sounds really easy to say. We all know that this is better, but the problem is that Python and R and things like that are just not made to work with 100 petabytes of data all at once. It's just not. Whereas your MPP database is. And that is part of the advantage of being able to work with Python inside of a database. And the data is already there. You don't have to worry about data transformation, data type mismatches, things like that. That makes your life a lot easier. Also, the more data you have, the harder it's going to be to move. That's kind of the essence of big data. You have a lot of data. It's really difficult to move. There we go. I brought in the space thing because data has gravity, right? Like planets. So it's really slow if what you're trying to do is take data and move it somewhere else and then do data science on it, because you're fighting that data gravity, you're fighting that inertia that you have to downsample. You end up having to try and statistically sample it, and then maybe having to do that multiple times to try and get a good representative sample of your really large data set and you have all of these, you basically end up with these compromises that you have to do to be able to get this done. And when you're done, you still can't put it into production. Somebody else has to rebuild it for you. So that's just not ideal. On the other hand, if you bring your model to the data, it's really easy because the database is the same in dev and test in production. That means that the place that you are doing your development is already well integrated with the ETL, with the wow, okay, words fail me. The BI tools, the ones that display your results, it's already parallelized. That's already where all the data is. You don't have to pull out samples. It's right there. And databases are really fast for doing data preparation, sorting, joining, filtering, all that sort of thing is already in there. And and then the need for speed at a reasonable cost, obviously. So that's where you get that scaling architecture. So here's another example. So Uber has something in the neighborhood of 100 petabytes of data. Probably a little less. They actually test at 100 petabytes, so they have probably closer to 60. And they're doing that same thing that I just talked about. They're pulling in the streaming data. They're putting it in a data lake in Kafka in this case, because they refine it using Spark. And then Kafka Parquet is actually where they store their historical data. Well, that's pretty cool. And they can put the recent hot data into their MPP database. And they can also, and this is kind of cool, because Vertica has very fast geospatial and time series data set analysis, they can actually do that right in place. So on the recent data, they can use Python. If you punch in, call in for an Uber car or, to get your food brought to you on Uber, that's a Python application. And it is doing the geospatial analysis to get that car to you fast or to get your food to you while it's still hot using Vertica. And so that Python and Vertica are talking to each other directly. And since Uber is awesome, they open source that interface. So the Vertica Python interface is now on GitHub and PyPy, and you can use it. Now, the other thing that is out there is JupyterPy. Not JupyterPy, VerticaPy, which is what you use for Jupyter interface, and under the covers, it uses that Python interface, and that's pretty cool. And that way you can use your Jupyter notebook to do your data science. I actually did a class on that with Prajal Singh, who is one of our data scientists, a couple of days ago, and you should go check out the recording if you get a chance. So what does Vertica bring to the table? Why Vertica? What does this MPP database give you? Well, first off, scale, because it is an MPP database. That means it works distributed, and because it's Vertica, this is actually unique to us. There's no single point of failure. There's no master node. There's no leader node. Nothing like that. So you have the capability to scale indefinitely. We have customers using as much as 60 petabytes, which I just mentioned Uber. We also have like the Trade Desk doing 15 petabytes in the cloud with 200 millisecond SLA, which is pretty awesome. It's like, that's about as good as it gets. And that speed also comes with concurrency. And that means if I have 1,000 users and they all want to use that data at the same time, that can happen. And it doesn't bog things down. One of the nice things about Vertica is it can isolate workloads, so I can train a machine learning model, and that will never slow down my executive dashboard. Those won't bump into each other, and that's powerful in itself. That gives you the ability to do BI and data science and have them live together and be happy. And you also have a lot of machine learning built into this database. So you have the ability, it has a good set of algorithms, all of which are already parallelized. You have the ability to do time series analysis, including moving windows and interpolation, and you can do geospatial analysis. You can do disparate time series joins. The data prep is really fast. There's just the whole end-to-end architecture is built in there, and that's pretty powerful. And it's got an open architecture, which means we integrate great with Kafka, with Spark. We can take Spark RDDs or data frames and read straight from them or write straight to them. We work great with a lot of your data science labs like Domino, things like that. We also connect to all your BI tools, all your ETL tools. So this kind of open architecture gives you the capability to have the flexibility to do all the things that you want to do. I think I kind of have beaten the concurrency thing to death, but I think that's really important because people don't realize that being able to 10 people being able to use your data is awesome. 100 people is 10 times better. 1,000 people is 100 times better. It really makes a big difference if more people can use the data at the same time without causing problems. And I swear it's not COVID. It's just me talking in Texas where the pollen is everywhere. All right. So you can do the end-to-end data science workflow. That's the other thing. And you can do it all in one place. So yes, I can check for outliers. I can normalize my data. I can get a window on my time series data. I can match things up, join things up. I can interpolate misleading values. I can find correlations. I can do all of that inside the database. I never have to move the data to accomplish all the things that you normally would use pandas for. And in fact, you can use pandas for it. If that makes you comfortable, you can write pandas code and it will happily do it inside the database at scale on the complete data set. It takes like one line of code to split your data set into a training and test set. And then you can train your algorithm, and the algorithms are right in there. Now, if you have a specialized algorithm that you wrote yourself, it's really easy to wrapper that as if it were part of the database. And you can put it in there and you can use it, and all of the rest of the workflow is already there. So you will only have to write that specialized bit of it. And you can evaluate your database, your model right there in the database. You have all the different, your ROC curve and your confusion matrix and your R-squared. You can figure out whether or not this is a good model. You can compare models. You can even do this with models that were built elsewhere. So if somebody trains a model somewhere else, they can save it in PMML, import it into the database, look at it and go, let me compare this with this other model that I trained internally. Which one is better? Okay, this is the one I want to deploy. And that's the coolness factor. You can then save that model as if it were a table. It has the same security, all the capabilities that a table has. It's that easy to save, and you can deploy it in minutes. One line of code, boom, and it goes from your dev, your test, to your production cluster, and that's it. That's all you have to do. It is done because your environment is the same in dev and test and prod. It takes minutes to get your work into production, not months, minutes. And that's incredibly powerful. And then of course you can manage your models. You can decide, oh, this model's getting old, the accuracy is not as good. Let me retrain, replace it with a new model. All of that can be done inside the database without ever moving that giant data that has that gravity that you don't want to have to take somewhere else. And if you have, if you're trying to do deep learning with TensorFlow, you can totally train that on a GPU machine, import it, put it to work. You can also train something here, export the PMML, and go put it to work somewhere else. So So what do we got? We got Vertica and we got Python, and that actually in the middle is the logo for Vertica Pi there on the left. And that's our Jupyter interface that lets you write Python, write SQL, write whatever you want to in Jupyter and have it do the job inside the database without you ever having to deal with the database interface. So you're working in Jupyter where you're comfortable, you get all the capabilities of Python, you get all the capabilities of the MPP database combined, and you get your stuff in production faster. So what does it give you? It gives you the capability to parallelize. And I think I mentioned that you can write your own algorithm, your own function, whatever you need to, and you put it in there and it will automatically parallelize it for you. And this works for R too. It has distributed R built in. So this gives you the capabilities to write a Python function, write a special algorithm for your particular use case or your particular company that's better than anything out there, fine. And then you can put it into the database and it will distribute it. So it will work at scale. And that is the coolest factor. Now, I already mentioned you can import or export PML. You can also import TensorFlow frozen graph. We can't at this time train a TensorFlow deep learning model inside the database, but you usually want a GPU machine for that anyway. On the other hand, you don't want to use your expensive GPU machine for your high scale production work, so that makes it pretty easy. You can train it on your GPU machine, import it, and put it to work in the database. If you want to learn more, be sure and check out vertica.com/Python. That has all the Vertica Pi docs and information that you might need. There's also stuff out on GitHub, that Vertica Python interface. So if you want to write a Python application and interact directly with the database that way, that's fine. Uber open sourced it. A bunch of other folks that do the same thing have contributed to it. So it is growing, and you are welcome to please contribute even more if you wish. Now I see the chat thing flashing, but I don't know what that means. So I'm gonna see if I can find out. Okay, so yeah, if you have any questions, feel free to enter them now. And I just these are just some quotes that I've captured as we go along, as talking to customers. And it's just powerful. It just really surprises people, I think, how much you can accomplish and how quickly you can get your work into production. And that's huge, because you just don't want to spend 6-8 months and never make it. There's nothing more frustrating than doing all that work and then never seeing it go into production. And if you want to learn more about Vertica, the Vertica Academy is free on-demand training, including certification. Just go check it out and learn as much as you want. And all of the machine learning capabilities are built into every version of Vertica, including the free community edition, which is up to 3 nodes, up to 1 terabyte of data. So if you want, you can just go get that and use it indefinitely. It's yours. Use it for your homework, use it for your personal projects, whatever you want to do. Learn on it, play on it. It has built-in some experimental data sets and really nice tutorials and stuff too. So that can help you out. So thank you guys. And I hope you learn more about this, because I would love to see more machine learning in production. Let me see, is there any questions? I will hang out for just a bit and see if anybody has any more questions. I've forgotten when this thing ends, so how am I doing on time?
You're doing great. You still have 15 minutes to go.
Okay, all right. Well, so I figured I'd just hang out and see if anybody has any questions, because I'm sure that there are some, but a lot of the times people don't think of them while I'm talking. So I know a lot of people ask me things like, how does it integrate with Spark? And I think I mentioned that you can read and write the RDDs. So a lot of our customers use Spark to do a lot of the ETL, a lot of the data preparation in the large pipelines, and sometimes they combine data and then feed it into the database. And then sometimes they do some ELT. How can you avoid being error prone? Is that the question? I don't think we're any more or less error prone than anything else. As far as I think if yeah, I'm guessing here on what you're talking about exactly, but I have gotten the question of if I have Vertica Pi and I'm writing Python code and it's sending SQL to the database, how does that translation work without causing some problems? And the answer is really that we have some really good contributors. There's a couple of data scientists inside Vertica who, of course, like working in Jupyter way better than they like working in SQL. So they happily contribute to that and help make that happen. And so far it's been very solid, but the way open source works is if you find an error, you fix it or somebody fixes it and it gets better. I mean, that's just pretty much the way this works. Over time, we expect it to grow and to get more and more robust. But right now we have multiple data scientists using it, and they haven't run into anything they couldn't handle. So I hope that answers the question. We're also in production in a lot of companies I think that you know about. We pretty much own the telecom industry. Pretty much any telecom you can think of uses this method. Oh, thank
So
you.
we have a few more questions. One is from Anuj Walia. He asked, can Vertica be used for dynamic aggregation with real-time data with a very high ingestion rate, and does it have a Java API?
Yes and yes. It does have a Java API. It also has a C++ API, a Python API, and R. So whatever you prefer. It is mostly built in C++, but the Java API is probably the second most commonly used. The Python API is used by some of our customers. A lot of them use the Java API, so that's pretty common. It's entirely up to you. And as far as what was the first part of the question? I'm sorry. Can you repeat it?
Can Vertica be used for dynamic aggregation with real-time
Dynamic
data?
applications. Yes, absolutely. A good example is the trade desk. We have a lot of ad targeting folks. So if I click on a web page, I have maybe a second or two to bid on that web page and to look at this person's browsing history and decide, so that that fishing boat that you looked at last week that follows you around the web, that's ad targeting. And somebody has to in less than 200 milliseconds, and this is important, go back and figure out what your history is, get all the bids for that, and pick a winning bid and place that ad. And that is one of our best use cases, because there just really isn't anybody who can do sub-second response on 15 petabytes of data, which is what the trade desk has. There isn't a lot out in the market that can do that. I think we recently had where we ran up against Redshift and Snowflake and us, and basically the use case was they had to do real-time dynamic in less than several hundred microseconds was their SLA, and the other two couldn't get it under a second. They just couldn't. We did it in 10 microseconds. So I mean, that's probably Vertica's biggest claim to fame is our performance at scale. And of course, the advantage here is that you can now take your Python code and give it performance at scale. Anything else?
So we have another question. Yes, we do have another question. It's from Eric Warner. He says, hi Paige, great presentation. I was wondering about Vertica's compatibility and usage with image data.
Thank you. We do not generally do image data necessarily, but we have a sister product called IDOL, IDOL. And a lot of times we're used in conjunction, we're used together so that we can analyze some of the data, and IDOL does the image data. A good example is Auckland Transport, which is the buses and train system that works in Auckland, New Zealand. They use both IDLE and Vertica together to basically analyze what the best route is for their buses and stuff to minimize accidents. And they use both all of the data that they have available, plus they use the image data from CC cams all over the city. And they can combine those because they have both products. So Vertica and IDLE together can do that. Vertica by itself is not great at image data. We can do text, we can do time series, geospatial, obviously structured and unstructured. We can do JSON, Avro, CSV, Parquet, ORC, a lot of different data formats, but image data, for image data, you need IDLE. Is that it?
Awesome. So we had one more question by Anuj. He asks also, columnar databases are poor with upserts. So what's the case with Vertica?
As far as how do we do upserts, or I'm sorry, repeat the question.
Yeah, sure. Columnar databases are poor with upserts. So what's the case with Vertica?
How good are we with upserts? It depends. Because we have the capability to do a dedicated subcluster that does nothing but ingestion and ELT, that gives you the capability to do streaming. You can pull data all the time in trickle loads. You can pull it in a little bit at a time and put it in a larger chunk, or you can, if you need it fast, then you can go ahead and put it in that quickly. We can, because we have that sub-second response time, we can ingest data very quickly, but it's always going to be in some kind of a micro batch. It's up to you how small that is. I mean, it might be as small as one message at a time, but it's kind of a trade-off. We can do upserts. We are not designed to be transactional. So that is one thing I guess that I want to make a big point of. It's like, yes, some people do use this as a transactional database, but some people also drive in screws with a hammer. That doesn't mean it's a good idea. It's not really what we're made for. We are an analytics specific database, but we do analyze streaming data. So we can do high speed coming in one message at a time very quickly data, but trying to do the transactions and it's not quite the same thing. And so we can do upserts in the term of streaming data, but we can't do it so well in terms of transactional data, if that makes any sense at all. I would say go to the Vertica booth, go talk to some folks, see if you can get a little more information from one of the architects, because my understanding of the difference is a little high level, a little vague. So there's some people who can give you a more technical answer. Did it help?
So let me check once again if we have any more questions. I see we don't have any more questions, so we still have 5 minutes. Do you want to say something?
Okay, well, be sure and fill out the survey. And thank you guys for coming. And I love, those were great questions. Thank you. A lot of times you get to the end and it's like, and everybody's really quiet and you're like, I don't know if they really got that or not, but you guys gave me fabulous questions. So those definitely made me feel like you got what I was saying and had good questions to ask. So I appreciate that.